Okay, good afternoon, everyone. So for this afternoon, we are going to talk about carbohydrates of physiological significance. So we are going to talk about carbohydrates that you will commonly encounter when you during your time in medical school as well as in your clinical practice. So again, I'm Dr. Ana Angelica Macalalad Josue, your professor for this afternoon. So for this lecture, here are our learning objectives. So we were going to talk about what is meant by the terms monosaccharide, disaccharide, oligosaccharide, and polysaccharide. You guys should be able to explain the different ways in which the structures of glucose and other monosaccharides can be represented. So there are different ways of presenting the structure of glucose and the other carbohydrates that I will be talking about in the next couple of slides. And you guys should be able to describe the various types of isomerism of sugars. And then you guys should also be able to describe the formation of glycosides and the structures of the different important disaccharides and polysaccharides such as your lactose, your sucrose, as well as your glycogen, your starch. And then uh, from the clinical perspective, you guys should be able to explain what is meant by the glycemic index of a carbohydrate. So as an endocrinologist, no, I deal with a lot of patients with obesity and diabetes. So I talk about this with my patients. So you guys should be able to also talk about this with your patients when you become full-fledged doctors. And lastly, we're going to briefly describe the roles of carbohydrates in cell membranes and lipoproteins. So the carbohydrates are one of the classes of macronutrients that is very important when you become doctors. And the most famous carbohydrate is glucose. No, this is the basic structure of, and it's the most important carbohydrate. And it's your glucose is a dietary carbohydrate that is absorbed into the blood. All dietary carbohydrates, no, is absorbed into the bloodstream when you eat food, no, as glucose, no, formed by the hydrolysis of dietary starch and disaccharides. So for example, when you eat a rice, no, when you eat rice, no, we're all Asians, so we eat rice almost every day. No, when you eat rice, the starch in the rice is broken down in the gut, no, by your digestive enzymes such as your amylase. And this is can you please mute yourself? So when you eat, no, a dietary carbohydrate such as rice, for example, or bread or potato, when it is digested in your gut, no, in your stomach, it's broken down into mostly carbohydrates, monosaccharides, disaccharides, and it is mostly absorbed in the bloodstream as glucose, no. And glucose is the major metabolic fuel of mammals, no, except for your ruminants, which are your cows and horses, no, and a universal fuel of the fetus. Another organ of the body that uses glucose as its main source of fuel would be your brain. Now, normally, glucose is absorbed into the cells with the facilitation of your insulin. Insulin is a hormone that acts like a key to your cells that makes glucose enter your cells. No? So in the brain, you don't need insulin for you to be able to utilize glucose in your brain cells. It's just passively diffuses into your brain. Okay? So glucose is also the precursor for synthesis of all the other carbohydrates in the body, such as your glycogen, your ribose, and your deoxyribose, which is in part of your nucleic acids, your RNA and your DNA. Your galactose, no? Your galactose is also a precursor. Your glucose is also a precursor of your galactose. And glucose is also the glucose residue, a carbohydrate residue of your glycoproteins and your glycolipids. So glyco for glucose, no? Glucose plus proteins equals glycoproteins. Glucose plus lipids equals glycolipids. Okay? So your glucose is made up of 6 carbohydrate atoms. So you count it from here. That says, wait, let me use my pen. So you have carbon here. That's carbon 1, carbon 2. This is your carbon 3, carbon 4, carbon 5, and carbon 6. So this is important in the next the purposes of our lecture later on. So carbohydrates can be classified into 4 classes. You have your monosaccharides, your disaccharides, your oligosaccharides, and your polysaccharides. So from the name itself, your monosaccharides is composed of one carbohydrate residue, no? So it cannot be hydrolyzed further into simpler carbohydrates. Your disaccharides is composed of 2. Your oligosaccharides is composed of 3 to 10. And your polysaccharides are composed of more than 10. No? So your important sugars can be further classified into trioses, which is composed of 3 carbons, tetroses, which are composed of 4 carbon molecules, pentoses, composed of 5 carbon atoms, your hexoses, which is composed of 6 carbon atoms, and your heptoses, which is composed of 7 carbon atoms, no? So your glucose here is an example of an hexoses, no? Your fructose is also a hexose, but their structure is different in such a way that glucose is classified as an aldose and fructose is classified as a lactose. So I'll explain that in the next couple of slides. So your disaccharides are composed of 2 monosaccharide units. And the examples would include your lactose, your maltose, your isomaltose, and your sucrose, as well as your trehalose. Oligosaccharides are composed of 3 to 10 monosaccharides. And lastly, your polysaccharides will be a condensation of more than 10 monosaccharides. No? Examples of which would be your starches and your dextrine, and your cellulose, no? Which is part of your plant cell wall, as well as your inulin. No? Polysaccharides are further classified into hexosans, which is composed of monosaccharides that are composed of 6 carbon units, and pentosans, which are polysaccharides composed of 5 carbon monosaccharides with 5 carbon atoms. So this is the basic structure of your glucose. So you have the straight chain forms. You will see that it's labeled, the carbons are labeled by their position. No? 1, 2, 3, 4, 5, 6. No? And then you have the ring form. This is your alpha D glucose. No? So you will see. And lastly, you have the chair form, no? Chair. It looks like a chair, no? There's your carbon atom 1, position 1, 2, 3, 4, 5, 6. Okay? But they're all glucose. So these are the different ways on how we present the structure of glucose. And then lastly, now we proceed to the types of isomerism that is found with glucose. So you have the D and L isomerism. D is for right and L is for left, no, isomerism. And you can see your OH group or your hydroxyl group in your L-glyceraldehyde. Glyceraldehyde is composed of 3 carbon atoms. Your hydroxyl part is on the left side. And your D glyceraldehyde, the hydroxyl part is on the right side. So similarly, you have your L-glucose where your hydroxyl part here in your 5th carbon is your on the left side, and in your D-glucose, it's on the right side. And the most common form of glucose is your D-glucose. Okay, that's why there's a star in there. So the next type of isomerism will be optical isomers. So when because of their characteristics, no, of the characteristic structure of your glucose, no, they have some form of optical activity. So what do we mean by this? No, when a beam of plain polarized light is passed through a solution of an optical isomer such as your glucose, it rotates in either two directions. To the right, which is dextrorotatory, and to the left, which is levorotatory. So when glucose is in solution, such as in your IV fluid, the formation of the glucose will be dextrorotatory. The rotation of the glucose when you pass a plain polarized light to it would be dextrorotatory. That's why it's commonly the glucose that you see in your IV fluids when the glucose is in solution is called dextrose. Okay? Your fructose, on the other hand, is a D isomer, no, left, no, similar to this one, no, but it's levorotatory when in solution. Okay? The next type of isomerism found with glucose would be your pyranose and your furanose ring structure. What do we mean by this, no? So when it's pyran, the structure is like this, no? So you see the whole, the ring is composed of 5, 1, 2, 3, 4, 5 carbon atoms. While in the furan, the ring is composed by 4, 1, 2, 3, 4 carbon atoms. Okay, so the most common form of glucose would be your D-glucopyranose. So this is also glucose, but in the form of D-glucofuranose. You see that the number of carbon atoms is still 6. Now, 1, 2, 3, 4. Too much. 1, 2, 3, 4, 5, 6. No? Okay? So, this one, 1, 2, 3, 4, 5, 6. Okay. But this one, the structure of the rings are different. The next type of isomerism found with glucose would be your alpha and beta anomers. So you can see that the carbon 1 here is called, there's an attached hydroxyl group here. That's your D-glucopyranose in the alpha form. No? This one is beta D-glucopyranose because the OH group, no, the hydroxyl group is located here. And the hydroxyl group, no, can change position in your carbon 1 atom. No? This is called your anomeric carbon. Okay? So do you see? Glucopyranose because of the ring structure, and then alpha because the hydroxyl group is here. Beta because the hydroxyl group is here. Okay? I hope you guys follow. And then another type of isomerism found with glucose are epimers. No? What are epimers? These are isomers differing as a result of variation in configuration of the OH, NH on carbon atoms 2, 3, and 4 of glucose. So if we differentiate it from anomers, anomers is mostly differences in the groups in the carbon 1 atom. If epimers, it will be carbon atoms 2, 3, and 4. So this is glucose. You have your hydroxyl group here, hydroxyl group here. When it becomes galactose, no, the hydroxyl position will be on the fourth carbon atom will be here. If it's mannose, the hydroxyl group in carbon atom 2 will be here compared to here. Okay? So you see that when you change the position of the hydroxyl group, the molecule or the monosaccharide becomes a different epimer of your glucose. Okay? So again, with your galactose, hydroxyl group in carbon 4 atom is here. So it becomes galactose. When this one in carbon 2, no, changes position, it's no longer glucose, it becomes mannose. Okay? And the last type of isomerism found with glucose will be your aldose-ketose isomerism. So, glucose is considered an aldose because it contains an aldehyde group, no, in your carbon 6. No, in your carbon 1, no? But in fructose, no, fructose is similar to glucose in terms of number of carbon atoms and number of hydrogen atoms and number of oxygen atoms, but the position of the different atoms is different here. So this now becomes fructose because it contains a ketone, this one. Okay? A ketone group, no, consisting of carbon and oxygen, and it has a double bond. Okay? So there's been a change in arrangement here from here. So glucose is an aldose. When there's a change in position in this area, no, you have the formation of your ketone group, it becomes a fructose. So this now is called a ketose, and they are isomers of one another. Okay, but they become different kinds of monosaccharides. Okay. So we talked about glucose as a hexose. Now we move on to your pentoses of physiological importance. So your pentoses of physiological importance would include your ribose, which is a main component of your nucleic acid, such as your RNA, no? And it also is part of the structural components of your coenzymes, including your ATP or adenosine triphosphate, your NADP, and as well as your flavin coenzymes. Your D-ribulose, no, it's an intermediate in the pentose phosphate pathway. Your arabinose, which is part of your plant gums. This is a constituent of your glycoproteins. Your xylose is also an comes from your plant gums, proteoglycans, glycosaminoglycans, and it is a major constituent of your glycoproteins. Cellulose is a metabolic intermediate and it excreted in the urine in essential pentosuria. This is a very rare condition. You don't need to remember this. Hexoses, on the other hand, that are of physiological importance. Of course, we talked a lot about glucose, no? As the most important carbohydrate that you should know. So its major source would be fruit juices, no, hydrolysis of starch when you eat carbohydrates such as your rice, your potato, canes or beet, sugar, maltose, and lactose. No, maltose and lactose are disaccharides. When you break them down, no, one of its components becomes glucose. Its biochemical importance, no? It's mainly what we refer to as blood sugar, no? Or plasma glucose. Its clinical significance is excreted in the urine. So when you do a urinalysis and you have high blood sugar, some of the glucose gets spilled in the urine, and you can see a +1 or +2, +3 in your urinalysis. That's called glucosuria, no? Especially in patients with poorly controlled diabetes mellitus because of hyperglycemia or elevated blood sugar. And of course, you have your fructose, no? Fructose is mainly found in fruits, no? Example would be fruit juices and even honey, the hydrolysis of cane or beet sugar and inulin, no? And if you have enzymic isomerization of glucose syrups for food manufacture, so if you're familiar with high fructose corn syrup, no, that's frequently found in food, no? Have you eaten Korean chicken? The coating of the Korean chicken has some high fructose corn syrup on it. Your maple syrup also. Some syrups when you eat, when you drink milk tea or even in your coffee shop, no? Some of those will have fructose on it, no? It's readily metabolized either via glucose or directly. Some patients will have hereditary fructose intolerance, which can lead to fructose accumulation and hypoglycemia. This is very rare. I've never encountered this. No? So galactose is another example of hexose. If you remember, it's an epimer of your glucose. And it's usually comes from the breakdown of your lactose. So your lactose is a disaccharide composed of glucose and galactose. So glucose plus galactose equals lactose. So when you hydrolyze lactose, it becomes galactose and glucose. So it's readily metabolized to glucose, synthesized in the mammary gland, no, as breast milk, no. And if you have problems with galactose metabolism, you can have hereditary galactosemia as a failure to break down galactose, and this can lead to cataracts. And lastly, another epimer of glucose is your mannose, and it usually comes from the hydrolysis of plant mannan gums, no? It's primarily a constituent of glycoproteins. So there's also such a thing as deoxysugars, no? Remember, you have ribose. We talked about this. This is an example of pentose, no? If it lacks an oxygen atom, it becomes a deoxyribose. So if you can see, no, in carbon 2, no, you have an hydroxyl group. If you remove the O here, you are only left with H here. Okay? So you have H here if you are not familiar with the biochemical shortcuts. You have H here, you have H here, you have H here also. And similar to here. Okay? H. So when you remove this one, you are left with just the H here. You have your deoxyribose. Okay? Now let's move on to your disaccharides. So disaccharides are thank you. Okay? So disaccharides are monosaccharides linked by a glycoside bond. So this is your glycoside bond, no? So as I mentioned earlier, no, if you combine if you combine glucose plus fructose, no, this is fructose. Remember, it's in ketose form. You form your sucrose. Okay? 3-halose is composed of 2 glucose residues. Okay? Your Maltose is also composed of two glucose residue, but you can see that there's a difference in the configuration here. Okay. And then here you have lactose. Lactose is composed of galactose plus a glucose residue. Okay, so you need to remember this. This will be asked in the exam. So sucrose, glucose plus fructose, lactose, galactose plus glucose, three halose, glucose, glucose, maltose, glucose, glucose. Okay? So disaccharides of physiological importance. Sucrose, this is in your common table sugar. When you drink your coffee with sugar, that's sucrose, no? Because sucrose, the table sugar is mostly comes from cane sugar. So you have your cane and beet sugar, some fruits and vegetables, no? If you have some genetic problems with the enzyme sucrase, no? You can have sucrose intolerance because you cannot break down sucrose. Lactose, of course, comes from milk, no? So including breast milk, cow's milk, no? If you have lactose intolerance because you lack the enzyme lactase, no? You can have diarrhea and flatulence if you take in dairy, no? So lactose is not limited to milk. You also have it in cheese, in yogurt, no? Maltose, on the other hand, no, is composed of two glucose residues. Just give me a minute. So you have, it usually comes from the hydrolysis of starch. Remember, in your gut, you have your amylase enzyme, in your mouth, no, you have your amylase enzyme. The first step in the breakdown of starch from your mouth, no? You can also find it in germinating cereals and malt. Isomaltose, also from the hydrolysis of starch. Lactulose, no, comes from heated milk, but usually lactulose is a synthetic drug, and usually we prescribe it for patients with constipation. It helps them with their bowel movement. And trehalose, remember, glucose plus glucose, it's found in yeast and fungi, and the main sugar of the insect blood, which is the insect blood, which is called your hemolymph. Now we move on to polysaccharides. No? The major example of polysaccharides will be your starch. Starch is a homopolymer of glucose, forming an alpha glucosidic chain called a glucosan or glucan. No? Glucan is the more common term that you will encounter in the future. So it's just like a chain, no, of many glucose residues, more than 10. And it's the most important dietary carbohydrate that you will encounter. No? You encounter it in cereals, potatoes, even legumes. No? Legumes are like your beans, no? Your mungo beans in the Philippines, it's very popular, and even other vegetables. The two main constituents of starch would be your amylose, which will compose about 13 to 20%. And your this one is the non-branching, no? As a non-branching helical structure of the different glucose residues. Amylopectin, which composed of 80 to 87% of your starch, consists of branch chains. I'll show you the structure in the next couple of slides, no? Which is composed of 24 to at least 30 glucose residues. This is the structure of your starch and glycogen. So if you can see, there are branching structure. Sorry, that was so. So you can see. Unmute. Okay. So you can see All right, so you can see the starch structure has several branches here. So I'll just briefly talk about this, no? In your amylopectin, the branch would be from your alpha 1 4. So your carbon 1 is attached to your carbon 4, and so on and so forth. So your 1, so 4. This is your 1. So there is an alpha 1 4 link. So alpha is this one, alpha. Alpha. Okay? And then you have a branch point, no? Which is from your alpha 1, carbon 1, and carbon 6. So when the bond, the glucosidic bond is between carbon 1 and carbon 6, the chain branches. Okay? Next, we talk about your glycemic index. So glycemic index, this one is the more gearing towards clinical significance, no? Glycemic index is the measure of its digestibility based on the extent to which it traces the blood concentration of glucose compared with an equivalent amount of glucose, usually rice or white bread. So there are certain foods that will have a high glycemic index, and it will raise your blood sugar very high, no, after you eat it, after you consume it, no. And there are those that have low glycemic index. It will raise your blood sugar to a lesser extent and to a slower extent as well. And it could range from 0 to 100%. 0, you cannot digest it at all. And 100% would be 100% you can digest it. No? So if you're, yeah. So these are an example of the different foods with a different glycemic index. So an example of foods that are of low glycemic index would be your apple, your broccoli, your orange, your carrot, your milk, and your bell peppers, your cherry. So your legumes, no? So this one is good, no? This one is good because it doesn't raise your blood sugar very high after you eat it. So this one is the one that we recommend to patients so as not to raise their blood sugar right away. Foods that are of medium glycemic index would be I think these are tubers, no? Kamote. I don't know, it's kamote in Filipino. It's like brown potato. You have your beans, your rice, I think this is brown rice, your wheat bread, no? Some ice cream, pineapple, and banana is a medium glycemic index. Foods that are of high glycemic index, this one is the one that we do not recommend to patients because it will raise their blood sugar very fast, no? You have your white bread, no? Your wheat, watermelon, I don't know what this one is. Potatoes, no? French fries, mashed potatoes. This one is, if I'm not mistaken, these are tacos. I'm not sure. Okay? So that's your glycemic index. So this one, and to a lesser extent, this one also medium is okay. But the high ones, no? Other examples would be your table sugar, sucrose, your milk tea, no? All right. So now we talk about earlier about glycogen, no? Glycogen is a storage polysaccharide. It's how your body stores glucose, either in the liver or in the muscles, no? Because your glycogen gives your body ready source of glucose whenever you need it. For example, when you're in the fasting state, you're not eating, when you sleep at night, of course, you're not eating, your blood sugar will start to drop. When your blood sugar starts to drop, your body needs glucose to raise its blood sugar back to homeostatic levels. So it will start breaking down glycogen through glycogenolysis in order to raise your blood sugar. And glycogen is mostly stored in the liver and also in the muscles, because in the muscles, when you're running, for example, no, when you are in a certain form of physical activity, or when you're running away from a lion, you need ready source of glucose to power your muscles. That's why your glycogen is there in your muscles in order to power that. Okay? It's also known as animal starch, and it can be form chains of 12 to 15 glucopyranose residue, pyranose because of its ring structure, no, with branching by means of alpha-1,6. So the residues are connected by your alpha-1,4 linkages, and the branching is connected by your alpha-1,6 linkages or your glycosidic bonds. Okay? So this is your branch. Alpha-1,6. That's your branch. And your in between the glucose residue, the non-branching part would be your alpha-1,4 linkages or glycosidic bonds. Okay. Other polysaccharides that are of clinical significance would be your inulin. This is a polysaccharide of fructose found in tubers such as your potatoes. Can also be found in roots of dahlias, artichokes, dandelions. No? Dextrins are intermediates in the hydrolysis of starch. When you break down starch, it doesn't become glucose right away. Sometimes it breaks down into dextrins. Cellulose, no? This is a chief constituent of plant cell walls. The one that's important to remember here is it's insoluble and not digestible by mammals. Why? Because it consists of beta-D glucopyranose units linked by beta-1,4 bonds. Unfortunately, we do not, mammals like us, no, except for cows, except for ruminant animals, humans like us, we don't have the enzyme that is capable of breaking down the beta-1,4 bonds in cellulose. So it's very, and that's why it's not digestible by us, because we don't have the enzyme to break this one. And it is a major component of dietary fiber. So when we eat, no, let's say you eat a leafy vegetable, and the dietary fiber component of that is not absorbed by the body, it's not digested, so it still comes out as fiber. Other polysaccharides, chitin. Chitin is found in exoskeletons of crustaceans and insects. So remember the hard shell of your crabs? That has chitin in it. No? All right. Pectin is mostly found in fruits. No? It is a polymer of galacturonic acid linked by alpha-1,4 bonds with some galactose and or arabinose branches. So pectin is mostly found in fruit. So when you make a jam, no, when you make a jam, have you guys tried making jam? So you squeeze in lemon in it. The pectin in the lemon will help, no, bind the jam into its jam consistency. I've tried making jam. Okay, and there's also a pectin. No, that's an alternate. That's the one that they usually made in the manufacturing way of it. But if you're just cooking at home, you want to make a jam, you can use the pectin from lemon. Okay? So the structures of some important non-starch polysaccharides. So you see cellulose. This is the beta-1,4 bond. So you see this one, this is the beta, no? 1,4 bond. Okay? Chitin has the beta 1,4 bond. Okay? But the polymer is different. This one is N-acetylglucosamine and this one is mostly made up of glucose. And then you have your pectin. Also, this one is alpha 1,4 bond. Okay? But made up of galactose and arabinose branches. Inulin here, you have your beta 1 sorry, this is your 1, 2 branch. 2. I don't know why. Beta 2, 1. Because this is a furan, no? Not a pyranose ring structure. Okay? So we're almost towards the end. Now, glycosaminoglycans, also called mucopolysaccharides, are complex carbohydrates containing um, amino sugars and uronic acid. So remember, this is sugar, amino, and uronic acids. And when your glycosaminoglycans is attached to a protein, it becomes your protoglycan. Your protoglycan, it forms part of your ground or packing substance of connective tissue, particularly, especially your cartilages, no? Type of connective tissue. It's rich in proteoglycan, and it can hold large quantities of water and occupy space, thus cushioning or lubricating other structures, no? An example would be hyaluronic acid, chondroitin sulfate in your cartilage, as well as your heparin. So hyaluronic acid in the skincare industry, it's very popular because it's a very good form of moisturizer because it absorbs a lot of moisture, no? Like here. Okay? And lastly, you have your glycoproteins. These are proteins containing branched or unbranched oligosaccharide chains. So the carbohydrate component and your protein component. And it mostly occurs in our own cell membranes. If you remember the structure of the cell membranes, there are structures there that have sticking out of big molecules. Those are your glycoproteins. No? So this will be the last carbohydrate of physiological importance that we will discuss. So let's go back to our learning objectives. Have we met our learning objectives? So remember, we talk about monosaccharides, no? We cannot break it down further into smaller components. Disaccharide, which is composed of 2 monosaccharides, oligosaccharides 3 to 10, polysaccharides more than 10. And then we explain the different ways in which the structures of glucose and other monosaccharides can be presented. And you have your straight chain, you have your ring form, you have your chair form. Remember that? And we also describe the various types of isomerism of sugars. So you remember your anomer, no? And then you remember your anomer is from carbon 1. So that's an example would be, yeah. And then you have your epimers, no? Epimers example would be your glucose, galactose, mannose. And then you have your aldose and ketose isomer. And that would be your fructose and your glucose isomers. And then you also have the L and the D-glucose isomers left in D with your hydroxyl group. And then you also have, if I remember correctly, the optical isomers. The optical isomers would be your dextrorotatory and your levorotatory isomers. So when glucose is in solution, it's mostly dextrorotatory. That's why the name of glucose in solution would be your dextrose. Okay? I hope I did not forget any of the isomers. And then we also describe the formation of glycosides and the structures of the important disaccharides and polysaccharides. So remember the different disaccharides, you have your galactose, which is from lactose and glucose. You have your sucrose, which is composed of your glucose plus fructose. You have your mannose, which is composed of your maltose, which is composed of your glucose plus glucose. Your trehalose is also glucose plus glucose, but in a different form. Then we also talk about polysaccharides, your starch, your glycogen, those are polysaccharides. Remember, their linkages would be either a beta 1,4 or an alpha 1,4, or you have the branching part, which is your alpha 1,6, no? Glucosidic bonds. So remember your cellulose that has the beta 1,4 bonds that makes it indigestible by mammals except ruminants. And we also talk about glycemic index, no? The measure of digestibility. of your carbohydrates. So low glycemic index, example would be your apple, your broccoli, bell peppers. Medium would be your banana, and your high glycemic index, potatoes, table sugar, honey. Okay? And lastly, we describe the roles of carbohydrates in cell membranes, such as your glycoproteins. Okay? All right. So I think I've covered everything. I'm gonna stop recording now. How do we stop recording?